All right, guys, moving on with AP electrochemistry. We're going to take a quick look at what a concentration cell looks like. Just like for our voltaic or galvanic cell, I would like you guys to take a minute and draw what you see, reflect back on what we learned last week, and make some predictions about some stuff. All right, so here's our basic setup. As you can see, looks pretty similar to what we had before. So we got a piece, two pieces of metal, a couple beakers. Here we have zinc sulfate solution. This is 1 molarity. In the other beaker, I'm going to put 0.01 molarity solution. So the metals for both of these are both zinc. And I'm actually going to use the same U-tube. So again, remember, a U-tube is just some agar. And then I put potassium nitrate in mine. Again, we just need to have ions that can freely float about. So I lost my buddy, Chase. He's outside playing. Anyways, I'm going to put the 0.01 molarity stuff here. And so it's the same metal, the same solutions. The only difference is this is 0.01 molarity, and this is 1 molarity zinc solution. So I'm going to get my voltmeter out. All right, I got my red and black cables here. I'm going to hook my red cable up to the 1 molarity. I'm going to hook my black cable up to my 0.1 molarity thing. So remember, in life, just like in the chemistry world, everything always wants to be equal. Everything wants to be the same. So I know this doesn't look like it's very fancy or anything. And if you look at my volts are very minimum. And actually, it's a negative voltage. So what does that tell me about my clips? That's right. It tells me that they are backwards. All right. So my flow of electrons was reverse in terms of what should happen. So I have a 0.02 volts, which is very, very tiny. So if you don't have this drawn out, pause the video. This is what your drawing should kind of look like. This is a concentration cell. So pause the video. All right, now that it's unpaused, let's go ahead and write down the Nernst equation. So this reaction, this 0.02 to, it's only 0.01. What's going to eventually happen to my voltage here as this this unexciting reaction takes place? My voltage is going to eventually do what? That's right. It's going to go to 0. So if you think about this, we'll mark this up a little bit. So remember what this little 0 means. It is not 8 degrees. It's at standard conditions. Standard conditions for reduction potentials is 1 molarity. And so if we were looking at zinc, just doing what zinc should do from your homework packet the other day, blah, 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 here we are. So zinc has a reduction potential of negative 0.76. If you subtract negative 0.76 from negative 0.76, you get 0, right? And that is at a 1 molarity solution. So when you look at your Nernst equation, that's 0. All right. So we are trying to figure out how are we getting this voltage. Oh, almost 0. 0.01 voltage. How are we getting that? Well, this is the Nernst equation. This is a constant. This is how many electrons we have moving about. I know how many electrons I have moving about based on zinc, right? 2 electrons moving about. And then I have the natural log of zinc over zinc. So we're looking at these different concentrations. So if you look up here at our picture, this is a 0.01 molarity solution. This is a 1 molarity solution. So in order for me to get that value of 0.02 or 0.01, what's going to happen? So natural log of what type of number would end up giving me a value? So I guess the question is it dilute over concentrate or your concentrate solution over your dilute? And so you could play around with numbers, you could throw things in your calculator, but you're going to figure out that it is always going to be your dilute over your concentrate. So in this case, it'd be your 0.01 over 1, and you would get your amount. So in terms of your reaction, let's think about what's happening. All right, is this my cathode on the left, or is this my cathode on the right? Again, the setup is the same, right? So what does this solution want to do? Does it want to get more concentrated or less concentrated? What does this solution want to do? Does it want to get more concentrated or less concentrated? So remember, they kind of want to meet in the middle, right? They want to get to that equilibrium point. So this wants to get more dilute. The 1 molarity wants to get more dilute. The 0.01 molarity wants to get more concentrated. So as you look at your sides of your drawing, what wants to do what? So in order for the 0.01 molarity solution to get more concentrated, this must be oxidized. And if it's oxidized, it is my anode. Now, how do I know that? Well, oxidation means that this metal is going to turn into the ion, all right, making this solution more concentrated. On the other side, we have our fat red cat. This is reduced. This is reduced. This is my cathode. Remember from notes last week, this is my fat red cat. So because it's my fat red cat, this piece of zinc metal is getting fatter. It's gaining mass. The zinc is coming out of solution. It's turning it from zinc aqueous into zinc solid, right? So again, that's kind of how you figure things out. The voltage on concentration cells is never going to be very large, and as we can see. All right, that's all we got for concentration cells. Email me with questions.